I'd like to do one more application problem right now. And the big thing I want to remind you of here is what to do if you're given basically 2 points on the exponential instead of a growth or decay rate. So we're told that a home is purchased 4 years ago for 240,000 and then sold for 290,000. So that's supposed to be now basically. If the value continues to increase exponentially, we want to know when the house would be worth $500,000. The first thing we'll need to do here is to set up our equation. And to do that, we're going to need to decide what our starting time is. And you actually have choices here. I think my favorite choice would be to have our time start counting at that 4 year ago point when the house was worth 240,000. There are ways you could do it where you make now be the starting time and you think of that 240,000 as like t equals -4, but I think that's slightly more confusing. So I'm going to say t equals time since $240,000 value, something along those lines. So my formula is going to have an A value of 240,000, and then I need a growth rate to figure out when it's worth $500,000. If you're ready for it, I would say I already am thinking that what I need to do is set this equal to 500,000. So we can put that there now. So I need to know what the percent increase was from 240 to 290,000. And again, there's multiple ways to do this. We could say, okay, I started at 240 and I increased to 290. So if I take 290,000 divided by 240,000, I can knock off some zeros. And I get about 1.208 and then 33333 forever. So that would be telling me that the property value increased by 20.83% in 4 years. So if we want to use that, I would say 1.2083, and you can even put in a few extra if you want to save yourself some rounding error. But that's not every year, that's every 4 years. So that would be one possibility. Just to mention some others, you could think about this as a table problem. We're given 2 points, so we could say in year 0, we had 240,000, and then 1, 2, 3, 4, we had 290,000. So if we're thinking our growth factor B would have to be applied 1, 2, 3, 4 times, we could set up 240 times b to the fourth has to equal 290. And what this one would do would tell us the growth rate in 1 year instead of over the 4 years. So it would be equivalent. That is another option. If that makes more sense to you, use it. Whatever you like, you need to find a growth factor and you need to know how long it took to grow that much. And then from there, this becomes, again, a not too messy exponential equation. There are some big numbers and some decimals, so that makes it look a little messier, but the steps aren't too bad. We're trying to solve for t, and there's only one, so we're going to start by dividing both sides by 240,000. And I'm going to knock off some zeros. I'm not going to convert that to a decimal. I'm going to save all extra rounding error. I already have some in here. What did I do? 3 3s. So I don't really want to compound that anymore. So you can just keep writing the 50 over 24. We could reduce that a little more. Even if we want, we could cancel a 2 and make it 25 over 12. It's up to you at that point. Mostly I'm just interested in doing things that make me not have to write any extra. So I'm going to introduce a log in this step as well. I'm going to take the common log of both sides. Log of 1.208333 to the t over 4. That allows me to bring the t over 4 down to the front. And then we can multiply both sides by 4 to get rid of the 4. And we can divide both sides by the log of 1.208333, and that will give us our answer. And now that I've done all steps, I'm going to go ahead and plug it in to get an approximate answer. And I got roughly 15.51 years. And you want to be clear with yourself, and if you haven't defined your variable super clearly above, you'd want to do it now. That's about 15 and a half years from when the house was worth $240,000. So if you wanted to give that as a time, like since current time, you'd have to subtract 4. That's 11 and a half years from the now of this problem. So just make sure you're really clear on what your final answer means there. Otherwise, I think we're all set.